Welcome, ladies and gentlemen, to the Technical Forum of Hydrogen and Fuel Cells Europe. We have a lot of interesting presentations. We have one, I talked to the speaker right now, it sounds so much interesting. And the subject right now is an innovative CCM, MEA manufacturing technology. And the speaker is head of printed functionalities of the Fraunhofer ENAS. Applaud to Mr. Professor Dr. Ralf Zichner. Please come on stage.
Thanks a lot, ladies and gentlemen. It's my pleasure, and welcome everyone. Yeah, right, I would like to give you an insight into a quite new and complex method and technology to manufacture catalytic coated membranes, or MEAs. First of all, I would like to introduce Fraunhofer very briefly. Maybe you know about us before, because Fraunhofer is has a big number of institutes. It's a big family, but every institute is, stand alone, so to say. In this area, I figured out we have at least 8 of them, which are doing quite good work, a very excellent work in the world of hydrogen itself. It's a very diverse organization. And I'm with a small institute called Electronic Nano Systems ENAS. So we are working mainly with electronics, with MEMS, NEMS, but we are using also nanoparticles for the manufacturing of catalytic coated membranes. So we are right now 170 staff members. We have an annual budget about 24 million. And we are located mainly in Chemnitz, in the eastern part of Germany. We have also a part in Berlin and Paderborn. Quite nice environment. I'm working with this company since 2009. Today I would like to dive a little bit more into the technology itself. First of all, we are highly motivated to live this dream of the green and cost-efficient hydrogen. Of course, there are existing a couple of technologies so far to realize that, but of course, again, our aim is to use sunlight and generate energy to generate hydrogen, save this, and use this hydrogen later on when we need the power at a certain place and time. So, and what we can see here is, of course, we need both for the whole system, the electrolyzer as well as the fuel cell. So both things are very important. And when we look a little bit deeper to the technology, and I guess all of you know about that, the electrolyzer is built up like this as a very simple sketch, and looking very simple when it comes to fuel cell. Of course, the whole system works other way around. With fuel cell, we are generating energy, and with electrolyzer, we do generating hydrogen. But whatever, so when we look at the center, the heart of the systems, we found out that we have all the time a membrane, anode and cathode. Of course, that differ in respect to the technology. So for electrolyzer, we have iron oxide, we have platinum, and here we have also only both platinum. And I forgot to mention, I would like to focus only onto the low temperature PEM cell, so the whole system works typically at a temperature of 80 degrees C, and there are some advantages in this area also in respect to the high temperature electrode membrane type. This is, for example, they are more efficient by use of high quality hydrogen and more dynamic, something like that. So whatever, this is only the basic. And I would like to show you right now what is the manufacturing technology today to manufacture the membrane and the anode and the cathode. I would not like to focus on the bipolar plate or GDL. It's only all about the CCM. So state of the art is looking like that, and you know about that. The very first step is you use a decal printing process or even screen printing and generate or manufacturing the anode on top of a decal substrate. That's not the membrane, it's only the decal. And this process is done by Slotter. As I mentioned, I do have a very small sketch here. And the second thing is also needed. You do the very same for the cathode. That means we do have 2 manufacturing steps so far. Finally, and this is the more important step here, we bring both decal substrates, so the anode decal and the cathode, together, and also together with the membrane. At this position, the membrane will be the very important part, and we do something like lamination. And a time-consuming and, of course, energy-consuming process. And what happened here at the lamination process, and this is very important to know. Again, I do have a sketch with me here. The yellow thing is the decal, and the slot die generate a big black layer, right? For example, the anode or even cathode, whatever. And after lamination, there is something left here onto the decal, which is not part of the final CCM onto the membrane. That's very important. So first of all, the substrate, I mentioned the fully layer, and everything which was here before is now laying on top of the membrane and is really part of the later fuel cell or electrolyzer, doesn't matter. But the critical thing is here, you do have remaining material on this decal material, and this is not really cool because this material costs money, a lot of money. You know about the fact that these inks are crazy expensive. I'm normally working with silver inks, copper inks, gold inks. You know about the fact that platinum-based or iridium even more costs. So I need a safe in my lab to store these materials. All right, this is state of the art. And what is now the process we developed as Fraunhofer Institute? They're looking completely different. The process, first of all, is shorter. So we are starting directly with step 1 and 2 in parallel, and we do printing the anode and cathode directly onto the membrane without any decal. We don't care about the decal. We are using inkjet. This is maybe also know from you, all of you use inkjet in your home office to print colorful pictures, to print in text, whatever. We use something similar, a little bit more industrial style, and apply the inks directly onto the CCM. And this is a little bit of tricky, so to say, but it's possible. It's looking quite good. So with that, we do not need any intermediate support, to be sure, because we print directly on top. We do not need any lamination process, and we do not need any recycling, because with inkjet we are able to print exactly the shape or the size of the CCM which you would like to have. And you can directly, with one click, change it from a small size to a big size, even middle size, whatever. It's fully digital. And more our main goals with that is we are reducing with that 33% of the whole process. We are saving 3% of the material. That's exactly the material I mentioned to you, which left on the decal normally. And with that, we are so close to reach that, but we are not really there so far. We would like to reduce the whole process cost of this CCM up to 30%. This is our aim. And to get to this point, you need at least 3 parties of knowledge. First of all, the very important thing is you have to know about the inks. So far, there is no ink available for inkjet printing catalyst-coated layers. Unfortunately, because normally I would like to buy it. But in this case, I figured out that we have to develop this by ourselves, and we did. That's the first thing. The second thing is you have to know about the whole inkjet process. And to be honest, our inks are developed directly to one specific kind of printheads. There are thousands of printheads available on market, small one, big one, industrial one, whatever. The ink should be addressed to a very defined process and inkjet hardware. But it's no need at all to build up or to develop a new inkjet printhead. Doesn't matter. The hardware is existing. You only have to use it. And the last thing is, of course, we need something like a high-speed inline control. Because it could happen that dust, for example, occur something like a spin hole or something like cracks or whatever. So our system allows to have a look inline whether there is any damage. And in case there is any damage, there is another inkjet module which could print exactly on this area, again, the very same type of ink to repair them. So finally, in our machine is 12 meter long, but whatever, we are not a manufacturer of machines. So we bought a machine and adjusted it to our sense. Again, our motivation is to figure out how it works and transport our knowledge to all of you. And I forgot to mention, we are part, as Fraunhofer, to a huge public-funded project consortia. So this is called H2 Giga. We are focusing right now on the production of electrolyzers. This is quite good. So there are a lot of money into that. A lot of people are participating with that. In case you have further question in respect to this big consortia, because we are not the very own, we have a lot of Fraunhofer institutes are working in this area. Please feel free to visit the hall number 5 at booth A06. I will not be there. My colleagues will be there because I do have a booth underneath there. But whatever, this is something interesting. And it's called Referenzfabrik. I'm very sorry, it's a German word, but this is a little bit more than only CCM. All these Fraunhofer institutes I mentioned here, IW, we are ENAS, IPT, IPA, IMWS. Together we are working on to a virtual fabric as well as a real fabric to figure out whether the new technologies are working in the high-speed way we would like to address. So a lot of institutes are working together to be able to manufacture in high speed, high quality CCMs, and not only CCM, it's all about also bipolar plate. Finally, the full electrolyzer comes out of everything. Yeah, and with that, I would like to thank you for your attention. Thanks a lot.
Yeah, thanks a lot for this dynamic and concentrated, interesting presentation. Are there any questions from the audience?
Well, I would like to ask you, what is the main drawback of Inject printing? What it is not the chosen state-of-the-art technology at the moment?
Yeah, so she asked, what is the tricky thing here? The tricky thing is here you apply a liquid, a very low viscous liquid directly onto a membrane, and this membrane will suck off the liquid and expand. So this is something tricky. That means we have to be quite fast. We have to apply the material, we have to heat it up to have a stable and homogeneous closed layer. In case you are not fast enough, you will become cracks, deforming, and other crazy stuff. And the second thing is also to have an ink which is able to realize the functionality at all. So this is not comparable easy. I presented today, to be honest. A lot of people are working on that since a couple of years. You're welcome.
One more question. Last opportunity.
Thank you, Professor, for the nice talk. So I have basically 2 questions, if it's allowed. First question is regarding the application of your CCM and MEA in terms of electrolyzers. Is in AEM's alkaline water electrolyzer was in PEM?
It's PEM, of course. It's only PEM technology.
Second question is that in terms of your technology, I'm curious about bending force. How can you fix your catalyst on surface of the membrane so good during the electrolysis and do so on? How can you hold the stability?
Yeah, so he asked again, what about adhesion? This was the question here. Of course, we add some additives into the ink, which allow us to have a quite good adhesion. So that it's really fixed on that. You can use your finger and scratch it what you like. That's quite good. It's all about chemistry.
One last question. Very last chance. Okay. So I would like to thank you very much, Professor Dr. Ralf Zichner.
Thanks a lot.